Good morning and welcome to Protektive Pak's webinar on ESD control for material handling. I am Mike Horngren. I am the marketing coordinator for Protektive Pak, and I'll be assisted today by Greg Heckler, who is the DII Western Regional Sales Manager. We'd like to ask you to go ahead and submit questions as we go through. You can enter them into the question module of the webinar program. We'll take a break about halfway through to answer a couple questions, and then near the end, we'll go ahead and take another break to answer some final questions. The questions will be monitored by Alan Claude and Jeffrey Brake. So what topics are we going to cover today? We're going to go through the Protektive Pak Impregnated Corrugated Material, what you need to do for handling of ESD sensitive devices, and then we'll finish out with some product demonstrations at the end. So right off the bat, the Protektive Pak Impregnated Corrugated Material meets the ESD Association requirements for ANSI ESD S541. This covers packaging materials for the protection of static susceptible items. Now, this covers both inside of an EPA as well as outside of the EPA. So what is it that makes Protektive Pak's Impregnated Corrugated Material the best choice when it comes to ESD control packaging? In this case, it's the unique buried shielding layer that's within the material itself. As you can see from this microscopic cross-section of the Protektive Pak material, the outer surface is static dissipative, but within the liner board itself is a buried shielding layer, and this is a carbon-loaded layer that's only 0.002 of an inch thick, and this provides discharge shielding for the material compared to our coated material from competitors, where that carbon-printed protective material is just printed on the surface, but it's still craft material underneath that doesn't provide ESD protection. Now, one of the benefits of our impregnated corrugated material is that both layers of this liner are mounted to the fluted medium. So not only do you have two surfaces that are static dissipative on the outside, but within that you have two buried shielding layers to provide your ESD protection as well. Protektive Pak, we offer a range of corrugated material options, ranging from our thinnest at 1/16 of an inch E-flute, and it ranges all the way up to our 5/16 inch double wall, which is a combination of B and C flute. The majority of our products, though, are manufactured out of our 1/8 of an inch thick B flute material. And right away, you can see the big difference of our material versus the competition. With a Protektive Pak box, even if you have some surface damage where that static dissipative surface has been rubbed away or it's been peeled off by tape, if someone's closing a box that way and they have to peel it off to open it up, it still retains its ESD properties thanks to that buried shielding layer to provide protection. The coated box, on the other hand, because it's just a thin surface application, through repeated wear and tear, or if someone tapes the box shut and they peel that tape off to open it up, that static control there is removed. Now you've made the box more susceptible to letting ESD damage get through and damage the components. So what are the important details when you need to handle these ESD sensitive devices? So we'll go through the ESD properties of our material, we'll cover its durability, and we'll go through a series of application specific packaging that we can do. So right away, like I mentioned before, the surface of the material is static dissipative. It measures 10.6 to less than 10.9 ohms per the test method listed. Also, though, the material does meet the shielding discharge requirements of less than 20 nanojoules. We had this material independently tested through a third party to test the results, and we came out to 2.28 nanojoules, far exceeding the required less than 20. In terms of strength and durability, it's important to know that these boxes can withstand the rigors and abuse you will put them through. As I mentioned before, we're using 1/8 inch thick material, and the industry standard for that is 200 pounds on its burst test and 42 pounds for an edge crush test. Now, this is the weight required to actually burst through the material and poke a hole, or for it to crush down and weight. And as you can see, Protektive Pak far exceeds that requirement. In terms of its durability, on the sloughing test, there is negligible surface damage on the Protektive Pak impregnated corrugated material. We've tested this through hundreds of cycles, and there's minimal surface damage even after repeated use. So if you're putting stuff on a storage container and sliding it on and off of a shelf, This material will hold up to that wear and tear abuse. On a coated box, that stuff can come off within 10 or 20 cycles of moving it on and off of a shelf, so it doesn't have the long-term durability that Protektive Pak's impregnated corrugated material has. Some additional benefits to our impregnated corrugated material. It is manufactured from 100% recycled paper, and it's completely 100% recyclable. And it also contains low sulfur content. Coated material, this can be made with a combination of recycled paper and virgin paper. And what that causes is the sulfur content inside the material to be either high or low, which can cause damage down the line through corrosion. The material itself is manufactured by one paper mill, and it's all computerized control. So our liner has consistent high quality results every time it's run through the mill. The finished sheets themselves and all products that Protektive Pak makes of our impregnated corrugated material is all proudly manufactured here in the United States of America. Now, in terms of applications, your ESD sensitive devices is more than just shipping and storing. The Protektive Pak product line can offer you a variety of applications within your facility, whether you're using stuff in assembly, you're doing stuff in inspection, engineering. We can manufacture a product that can fit that need. The biggest part of what we do, though, when it comes to shipping is returnable packaging applications. Our storage containers on implant handlers, you can fill them with your components and you can send them off to the next facility that needs them. And when they're done, they can take all the components out, they can break these boxes down, they can palletize them flat, and they can send them back to you, and it saves on shipping costs over time. In terms of the product offering, like I mentioned, we have a variety of products, whether it's open bin boxes, circuit board shippers, tech trays, but the biggest product lineup that we offer is our Protektive Pak impregnated corrugated implant handlers. We have over 200 variety in stock. They range from multiple cell sizes, multiple heights, multiple sizes. We can pretty much find a box to fit your needs. If you give us 3 dimensions, we can find the perfect cell size to fit your board or your component. And if you have a size that we don't, if your board size doesn't quite fit, we can always do a custom application in that situation. And we can do customs for pretty much anything you'll need, whether it's shipping or in facility use, like our 2 example trays on the right-hand side there. Jeffrey, do we have any questions to start off with?
We do, Mike, we do. First question, Mike, can you hear me?
Yes, I can hear you just fine.
Okay. First question, there was no mention of S2020. Can you explain the relevance of S2020 for packaging?
Yeah, so S2020 itself doesn't actually have any details for the requirements or the testing you'll need to do to spec in your ESD packaging. The S2020 standard actually references that you should use the S541 standard when you're going to do that.
Okay, so it's referring it to, so S2020 refers to the 571, right?
Yeah, it refers back to using the 541 standard to spec in your material to determine the needs you need, determine the needs for your packaging, as well as the relevant tests you'll have to perform to spec in that box.
Okay, thank you. Alan, can you unmute yourself? I think you're available. I have a question for you. I'd like you about, Alan, you there? Alan?
I'm here, Jeffrey.
Alan, can you elaborate on what can you describe the first article process for customs when we do that?
Sure. Sure. If we get a request for a custom item, which would be some kind of a modification of a standard product, the first thing we'll do is, clarify what the customer wants, and then we will work up pricing for that item. Once the pricing is determined as being acceptable, then we would make up a first article sample and send out to the customer for approval. This is an actual sample that would be just about exactly what the customer is going to receive. We run that on our sample table. When the customer receives the first article sample, they will review it, test it, do with it what they would normally do for the final product. And there's a label that comes with the sample. They would sign off on the label as acceptable, return it back to us. Once we get the sample returned here and a purchase order from the customer, we'll manufacture that custom item.
Okay, thank you.
Uh-huh.
I have another one for you, Alan.
Okay.
This is kind of two questions from two different people working together. How many times does an ESD corrugated box need to how many times can it be used, and what's they're asking what the shelf life is.
Okay.
Can you elaborate on that?
Sure. Shelf life is going to depend on how much the customer abuses or doesn't abuse the box. Depending on the design, different designs are much stronger than others for the particular application. The material itself will not degrade or dissipate its properties. The properties that come with the material are extremely durable. They're not going to go away. How many times can you use the box if you're doing, let's say you're shipping a circuit board shipper box? It's going to go back and forth multiple times. It just depends on how much the person abuses the box. If they're doing, for an example, an implant handler, the standard implant handlers are extremely durable. I think we're going to give a little demonstration of that later in this webinar, but the boxes themselves are made with triple thickness ends, double thickness sides, double thickness bottoms. And we've had people, it was about a week and a half ago, we had a request from somebody who had a box that was 26 years old, wanted to replace them. So much of it depends on just how you abuse it, but it'll take quite a bit of punishment depending on the style.
But I think the important part there is that the material itself doesn't degrade, right? It's going to still hold its ESD properties that we described earlier.
Correct.
Okay. I think that's good for now, Mike. Let's go. I think you're going to have Greg do some live demonstrations. I do have some more questions that we'll answer with Greg because I think they'll be better suited for a demonstration or a live type of answer. So go ahead and do that.
I'm going to go ahead and I'm going to switch everything over to Greg Heckler right now to do the product demo.
Hi, everybody. Thanks again for coming. My name is Greg Heckler, as Matt mentioned before, and I'm the Western Regional Manager for Desco Industries. Some of you may already know me out there, but for those that don't, I'm an ESD certified technician. I've got about 39 years of experience with ESD controls. So I'm going to demonstrate some of the electrical properties of the product or how you would go about doing that. And I'm going to describe some of the features and benefits of this product as it pertains to a product that you would want to use for your material handling process, or in common sense term, how am I going to move my product throughout my facility, not only ESD safe, but also physically safe. So one of the things that Mike started discussing first is the S2020 standard as well as the S541 standard. And I'll just touch on that again. The ESD standard S2020, pretty much most of us know that that's the Bible for the majority of our static control process. But they separate material handling from that and use what's called the S541 standard. And within that standard is all the test parameters. It describes the difference between a dissipative material, a difference between a low charging material, and the difference between a static shielding material. So that's the standard that you would use to define to make sure you've got the right product for the application. And then it also gives you all the test standards by which you would use to test some of these products with. So one of the things that is confusing to some people is what's the difference between dissipative and shielding? Well, dissipative basically just means that if it has a charge on it, it will dissipate that charge away. Okay, it's really as simple as that. Static shielding means that if I have a charge on the exterior, will it keep it from going through to the interior? So there are some products that may just need to be dissipative or low charging, like a shop traveler, a sheet protector, or something like that, what a lot of people would call an anti-static bag or foam. Then there's times when you need static shielding, and that is when I'm transporting things. That could be within your EPA, Electrostatic Protected Area. It could be particular outside of the EPA. So a perfect example of that, which we all know for the most part, are what we call static shielding bags. The reason these were invented a long time ago was because regular pink poly bags wouldn't keep a charge from going through them. So in order to have a static shield, you need a conductive layer. And in the case of the modern metal in static shielding bag, what we have is we have a dissipative coating on the polyester exterior layer. We have a dissipative polyethylene layer on the inside. And then in between those, we bury aluminum, basically. It's sputter coated on there. So basically it's so thin you could see through it. So not only do we have a product that doesn't charge up because it's dissipative inside and outside, but we also have a product that will keep a charge from going through it. So the in-plant handler system, or the dissipative corrugated material that Protektive Pak manufactures, is pretty much the same thing as a static shielding bag, but it uses carbon instead of aluminum. So the importance of having this dissipative outer layer is that we don't want something that's too conductive. In other words, we don't want a doorknob. If I were to walk over and have a charge on my body and touch that doorknob, that would dissipate that charge real fast and I could get a shock by that. So also creates a lot more energy. So when we want things that may touch our parts, we want those surfaces to be dissipative. So we'll dissipate that charge, but it will do it slow enough so it won't create an instantaneous discharge. So that's the importance of having the dissipative layer. Now, that layer would typically be, in order to avoid what we call charge device model damage, greater than 1 × 10⁶ and less than 1 × 10⁻11. However, on this product, we go below 10⁹. So this is actually a groundable product also, which I'm going to demonstrate, okay? And then what we do is bury that layer. So whether it be the lid of the box or the exterior of the box, or I'm going to talk to you about the divider system and everything else, that material is dissipative outside and it has the buried shielding layer. So I'm going to show you an example of that and show you some testing that we do. So this is a piece of the corrugated material. Here's the perfect outside. This one we shaved down to show you the dissipative exterior, but also to show you the custom or the black carbon layer down here that's conductive. So in order to measure packaging materials, the S541 requires that you measure these materials, the resistance in ohms of these materials, using what's called a concentric ring probe. And that's basically like your 5-pound weights, but there's a probe and a probe. So I have a conductive interior ring here, and I have a conductive exterior ring or a probe outer ring. So it's measuring the resistance of your material between these 2 points. So first I'm going to measure the exterior of this material. Now you have to bear with me because our cameras here don't have a high enough refresh rate, so it's going to jump around a little bit, but I'm going to tell you what the reading is. So it takes about 10 seconds to go through this testing process. So the measurement is 8.95 × 10⁶, okay? And so that's a great dissipative material. In fact, it's on the lower end, so it will dissipate a charge even more completely and faster. So now I'm going to measure that conductive layer. This test will go a little bit quicker because the material is more conductive. So 6.32 × 10⁵. So it's that buried layer that gives you the shielding capability and allows us to obtain those measurements well below that 20 nanojoule upper limit of the standard. Now, another thing I can show you as well is how the product would dissipate a charge. So I have a static field meter here. We turn it on. Many of you know what a static field meter is. This is something that you would measure at static charge on things, whether they be plastic bags or whatever you want to measure. And then I have a couple of paddles here. One is a solid piece of acrylic. The other is a piece of aluminum on a piece of acrylic. So this represents a static generator. This represents an isolated conductor. This might be you not wearing a wrist strap. So that's what I'm going to say. So let's say I'm walking across the floor, okay, and I put a charge on my body. And I want to measure that charge. And I could show you that's got about, hopefully you can see that okay, that's got about 3,000 volts on it, all right? Now, if I want to see if my material will dissipate that charge, I can simply touch this box. And by the way, the box is sitting on a grounded ESD mat. And I can bring this back in and show you that it completely dissipated the charge off of the material. So that's what we mean, not only when materials are static dissipative, that they won't generate a charge, but if they're low enough in conductivity, they will also properly dissipate that charge. So that's one of the important things too, that you want to make sure that you specify when it comes to material handling products like this. They're going to be safe to not generate a charge, they're going to dissipate a charge, and in the case of this type of product, the anti-static shielding bag, they're going to shield your board from an existing charge. So I showed you basically the electrical properties, and if you have any questions, we can get to that. I want to show you a little bit about this abrasion resistance or durability that Protektive Pak has. This is a regular coated bin box, black conductive bin box, okay, with the exterior on the outside. And I've got a little fine sandpaper here. As you can see, it doesn't take much to abrade that surface layer off. And what's really important about this is that many of our material handling products take a lot of abuse as far as sliding things back and forth. I might be stacking them on shelves and I'm constantly pulling them on and off. I might be setting them on a wire, a metro type cart that I'm sliding my boxes on and off. So it's important when you test your products also that you always test the bottom of the product, because that's what takes most of the abuse, or it might take a lot of abuse sliding things in and out. So again, as Mike said, that's one of the problems with just the topically coated material. So I have another Protektive Pak container here, and I've been rubbing on this, as you can see, okay? And basically all we're doing is just knocking the shine or discoloring that material. So this material is extremely durable when it comes to outside forces like sliding things across, even on the floor. If you were throwing these things in the back of your pickup truck or company van or something, we want them to be durable. So this is an important feature of that product, okay? So another thing I want to talk about is, I'm going to open this one up here. This is, as you can see, as Alan mentioned, all this stuff is folded over with double sides, double wall thicknesses, etc. I wanted to mention another important part of ESD control when it comes to a product like this, and that's what we call an air gap, all right? Now, in a static shielding bag, we might have a little bit of air gap if there was air in there, whatever, but on a product like this, you can see that with these extra, this is where you would put your fingers in, for instance, on either side to pick up the product. We have this extra exterior amount of room around the circumference of the box that also allows for a longer distance for any potential charge to travel to go through the box. As an example, when you shock yourself on a doorknob and you see that charge come off your finger, that may only be 1/16 of an inch or 1/4 of an inch. That's because the farther the charge has to flow through air, the less strong or the lower the potential of that charge will be. So not only do we have these buried shield layers, but when you're designing a product like this, an air gap is also important. So that's a big feature of this product, okay? So again, double wall thickness. I've got a divider here, for instance. This is a single thickness here, but we fold our divider system over. So not only I have double the protection of twice the amount of corrugated, but now I got 4 static shielding layers and obviously the dissipative layer. So that's critical, okay? This also, by the way, while I've got these open, this is how this system works. I have a long one and I have a short one. And basically, this is how we configure our dividers by these slots right here, okay? So that's another nice feature of the product, okay? Another nice thing about this product too, say versus traditional plastic tote box, is that almost all injection molded plastic tote boxes are beveled like this, the sides. Plus they have about that much of an exterior lip of the lid going around on it. So when you stack these boxes up against each other, there's almost an inch of wasted space. With a Protektive Pak container like this, I don't have a lid here, everything is square, basically, these sides. And when you put the lid on, you only really have about 1/4 of an inch of extra space. So you can really stack a lot of these nice and neatly on shelving units, on rolling carts, etc., things like that, okay? And then also there's a number of accessories. One of them you'll see that I put my fingers through the box. These can be left in, or they can be punched out, either one. But if you don't want people putting their fingers inside, we also have these snap-in handles. So when you're, I shouldn't say snap in, when you're putting the box together, you would put these in. So this gives you a handle system by which I don't have to put my hands in the box. So that's one accessory. Another accessory is, how am I going to know what's inside of it? Static shielding bag, I can look right through it. Well, on this particular product, if you have circuit boards inside, something like this, etc., we have different marking capabilities. Like these are just little peel and stick identification systems, so I can slide an ID card in there or whatever I want to do. They're marked with the, this is our dissipative vinyl material. They're marked with the reaching hand also. Another thing too is a lot of people want to color code in their facilities. I might want to put a red piece of construction paper in there noting this is a box with RMA parts in there, or a green for good parts, things like that. We get that question a lot. So we have a number of ways to identify what's inside the container. Snap-on systems, things like that. So that's another accessory. Now for extra durability, I gotta reach down here. For extra durability, we also have this steel ring system. So when assembling the box, I can put a steel ring around the upper perimeter of the product, and that gives it a tremendous amount of torsional strength, and strength as far as pressure maybe coming down on the box as well. So this is an option too if you think you need it. And then for more physical protection, we also have foams that can be put inside the bottom of the container as well. So high density, low density, etc. So if you need some time of cushioning or shock absorption, you can order the containers with foam as well. And then lastly, as far as features go, all of our products meet the standard for identification. The S2020 requires that all of your ESD protected materials have the reaching hand or be identified as an ESD protective product. So that's the reaching hand, that yellow or this blue, okay? And this arc over that hand means that this is an ESD protected product. This is an ESD protected product. So you don't have to worry about marking them yourselves when you get them. And then as far as Alan touched on customs a little bit. Well, one of the things you might want custom is the printing on it. As an example, if you want your company logo on there, we can do that, or your company name. If you're a contract manufacturer and you've got 20 customers, I might want to make boxes up with that customer's name on it if I wanted to ship the customer's product back and forth. Or I may want to throw them again in my company van and run them over to my customer and bring the box back, or have them ship it back. So you can also custom identify these containers readily with different logos, names, colors, things like that, okay? So that's all I have for now as far as, oh, I want to touch on one other thing. Well, no, I think I covered that already. Anyway, we got any more questions, Jeffrey or Mike?
Yeah, Greg, let's start with, we do have some questions. Let's start with you since you're, can you explain the charging of the surface? Does it charge? Is there a tribocharging effect with? Is there a tribocharging effect with other materials?
Okay, tribocharging, like any other static dissipative material, would be very low, extremely low. If I rub, in fact, I can probably show you that. I have my field meter here. I'm going to take this piece of material and I'm going to rub it on another piece of our material, okay? So I can show you there's nothing on there. That's one thing. I could also, I've got regular slacks on right now. I'm going to rub this material on the side of my pants, and again, nothing. So a good static dissipative material, especially one this low in conductivity, is going to be a very low charging material. However, let's take the static shielding bag analogy. If I were to walk across this room ungrounded on my carpet and charge my body up, I could induce that charge onto the exterior of this bag or onto the exterior of this tote. And that's the whole point about not only having dissipative materials, but also materials that have shielding properties. So even though I might charge up the exterior of this, it's not going to go through it. And if it has a charge, when I bring it to my ESD workstation and I set it on my grounded mat, it's going to safely ground that charge away. So that's the importance of having both of those properties in a material handling product. Any other questions, Jeffrey?
That's actually another question. Can the boxes or the material be grounded? I don't know if you want to maybe demonstrate that with the R meter.
Right. And I mentioned that it is groundable, but I can show you that it's groundable. So I have one of my 5-pound weights. And again, I'm going to take my surface resistance tester. I'm going to take my black wire. I'm going to plug it into the ground on my workstation here. Plug my probe in. So now my tote, my material handling tote, is sitting on my ESD mat. My ESD mat's grounded back through my AC electrical ground. So I'm going to make my measurement again. And so this is what would be called doing a resistance to ground measurement, or RTG. So I have 1.56 times 10 to the 7th. I know it's probably jumping around, but 1.56 times 10 to the 7th. So you notice before my surface was 10 to the 7th and my RTG is 10 to the 7th. So yes, this material is less than 1 times 10 to the 9th and it can be grounded.
Gotcha.
Any other question, Jeffrey?
Yeah, a little bit more straightforward question. I know people want to know, or there's a question about how would you decide on the size of the implant handler for their application. So maybe, yeah, I think you have a circuit board there.
Yeah.
We can show them how you would measure that.
Right.
The other thing you always want to do is get a hold of our customer service department, and they'll walk you through figuring out what the best configuration is for you. But go ahead.
So on the Protektive Pak website, there's a little calculator that you can put your dimensions in, and it automatically pops out what the cell size should be, or the best cell size for your product. Now also, you may want to determine how many things I want to put in it. If these things were 5 pounds, I wouldn't want to put 60. I'd never be able to pick them up. So you might want to decide how many I want to transport also. But for the most part, you want to measure the length of the product, the width of the product, and the height of the product, all right? Now, the important thing to remember when doing this is how I want to put it in the implant handler. If I had a bunch of LEDs right here, I wouldn't want to set it on that end. I might want to set it on that end, or I might want to set it on this end. So you want to know your length times width and height, but I also want to know which way I want to put it in the box. So that's an important consideration, or thing to take into consideration. Any other question, Jeffrey?
I think that's probably going to be it. I think Mike, are you still there?
Yes, thank you, everybody.
There are some other questions, but we're going to. I think it would be better to follow up an email or maybe a phone call with some of these. They're a little bit more than what we can probably talk about here. So we'll do that after the presentation. Again, we appreciate everybody's questions and your interest. So, Mike, I think you have a few more slides. Is that right?
Yeah, I actually do have a short little video I'd like to demonstrate. As Greg mentioned in the demonstration, the implant handlers are incredibly strong once you fold them up. You have a wire frame in there and you have the divider set. So this was a video we filmed about a year ago. We did it as a little test. We took a Volkswagen Bug and we lifted it up with a forklift, and underneath the 4 tires, we put a fully assembled implant handler. And we wanted to test just how strong these boxes really could be. So after we put them under there, we lowered the Volkswagen Bug back down onto these fully assembled partition sets, and we let it sit there for a couple of minutes. And then so once we let it sit there, we went back and we lifted it up, and we decided to see what the results were of our test. And when we did it, what we found in the end was we just had a tire scuff mark on the lid, a little bit of an indentation on the lid, but once we pulled that partition set out to look at it, there was absolutely no damage inside the box itself. I'd like to thank you all for attending Protektive Pak's webinar. If you have any additional information, please feel free to contact us. You can go to our website, protectivepak.com. There is a contact us section and it will take you to the service at Protektive Pak email. You can also call us as well. Thank you all for attending.